Lions Rock Productions.
This is Jay Moore.
This is Greg Proops.
This is Jeffrey Reddick.
This is Dexter from The Offspring.
Nathan East.
This is Sebastian Younger.
This is David Labb.
This is Stuart Copeland.
This is Mick Gillette.
I'm Krista Verno.
This is Ryan Sick.
Hey, this is John Leon Guerrero.
Hey, I'm Mark Fowley.
Hey, and this is Pete A. Turner.
My name is Brian Keating. I'm professor of astrophysics at UC San Diego, and I'm the author of the recently released Losing the Nobel Prize. And you're listening to the Break It Down Show.
And now, the Break It Down Show with John Leon Guerrero, Mark Valley, and Pete A. Turner.
Yeah, we're sitting out here on Phil Green's deck. It's spring break, so Tim's here. He's Grandpa Tim, I suppose you would want to call him, sitting in here. And Phil's going to ride shotgun with me today, partly because I like Phil and like to hang out with him, but also because he's got his own podcast that we're going to produce called What's in Store coming up. So he's out here riding with me and working on his overall chops. And again, I like to hang out with Phil. So welcome to your first time officially co-hosting with us here, Phil.
Well, thank you, and I like hanging out with you.
Yeah, friends. And then I'm going to let Phil do an intro for you, Brian, and then we're going to get going.
Great. Sounds good to me, guys.
Yeah, in the intro, I'm getting a lot of my information from our friends over at Everpedia. And as you mentioned, you're a professor at University of California, San Diego, but you're also a public speaker, inventor, and expert in the study of the universe's oldest light, the cosmic microwave background, using it to learn about the origin and evolution of the universe. So I think that's really interesting things, and the expansion of space and how that really impacted our universe after the Big Bang is really interesting things.
Yeah, it's a big subject. That's for sure. The Big Bang. It's not just a TV show. It's a really important event in the history of the world and the universe and all of us.
It's so big, it's kind of hard to even start. Well, let's talk a little bit. I want to direct everybody to you on Twitter, and that's at drbriankeating.com. Brian spelled B-R-I-A-N. And also his website, briankeating.com, where you can find out everything about everything. You can buy his book there as well. So we can and you definitely should, because it's interesting. You guys were doing Nobel caliber work, and I guess we're going to talk about this in a minute, but then the Nobel Prize is highly esteemed and seen as this incredible thing, but also what you're saying, and I think you're right, is that it's highly biased towards certain things that don't necessarily fit the profile for what they like. This, for example, there aren't a whole lot of female award winners, and what it takes, the kind of research they award, forces the most innovative minds to do things that necessarily aren't in our best interests. No, that's not right. They aren't in the. You know what? I'm going to shut up and I'm going to let the doctor talk.
Yeah, well, when I started writing the book, it was intended to be sort of a memoir of this extraordinary event that I was a part of, which is this discovery of what we thought was really not just the Big Bang, really, but it sort of illuminated the early universe's birth. So the Big Bang is an event that really is still unfolding, in that the universe is expanding and it's cooling off. And you ask, what did it come from? Where did everything come from? And you're led to this, irrevocable conclusion that the universe must have been smaller and hotter and denser in the past. And how hot and how small and how dense it was in the past is unknown. But the question as to what happened to the universe after the first 3 minutes after its origin, we really understand most of the physics and the properties of nature going back in time from today, which is approximately 13.82 billion years after the Big Bang, give or take a year or two. And if you go back in time, we understand everything back to 3 minutes after the Big Bang. But physicists are kind of greedy, and cosmologists are greedier too, and we want to know what happened at time zero, because at time zero, some really mind-bending things could have happened. For example, time itself could have been created. In other words, if you're at time zero, how does a watch work if time itself came into existence at a finite point in the past? That's pretty mind-bending, and it's not known what actually that happened. But back in 2014, we believe we got much, much closer to the origin of everything by observing what we thought to be the imprints of the birth process, kind of the afterbirth of the universe, when it was not 3 minutes old, not 3 seconds old, not 3 nanoseconds old, but about a trillionth of a trillionth of a trillionth of a second old. Just phenomenally mind-bending, short, brief amount of time after the universe's origin. We claim we saw this aftershock of creation, and that set off aftershocks throughout the world of physics, but also the worlds of philosophy, theology. There are many, many connections between the origin of the universe and religious accounts of Genesis, after all. That is, in some cultures considered to be the tantamount process to the Big Bang. And then, of course, Nobel whispers started to spread like wildfire throughout my community. And I was one of the people on the short list of top vote getters in an informal poll to get the Nobel Prize, assuming that our discovery panned out and turned out to be verified and confirmed, which you can probably tell because my description does not include the words Nobel Prize winner, that I not only did not win the Nobel Prize, but in a certain sense I lost it. And the title of my book is an account of that, and it's an allusion to that event, but it's also a double entendre, if I'm saying that right. My French is rusty, but it really has a double meaning, which is that there are so many negative aspects of the Nobel Prize that I believe we should get rid of it. It should be lost. And it could be reformed in a way that I hope to champion as the future of science continues and progress continues within the field.
What did you lose out to then? Who took the slot for physics that you're going after?
Yeah, that's a very good question, because originally in Alfred Nobel's will, he endowed money for prizes to be awarded in chemistry, physics, medicine or physiology, peace, and literature. So those 5 awards. You may have heard of the Nobel Prize in economics. That's actually a misnomer. There's no such prize nowadays as the Nobel Prize in economics. It's actually known nowadays. It was added in 1968. And that prize obviously wasn't in Alfred Nobel's will. He died in 1896. That prize is now known by a very catchy, name that a PR firm must have come up with. It's called the Swedish Central Bank Prize in honor of the memory of Alfred Nobel. And the reason it has such a weird name is that the great grandnephew of Alfred Nobel, who had no children of his own, he never married, he was sort of a recluse in many ways, but his great grandnephew sued the Nobel Committee for illegally using the use of his great granduncle's name. And the reason for that was he believed that the Nobel Prize had become completely distorted from the desires that Alfred Nobel had. So in the beginning, there were these 5 Nobel Prizes, including physics, but astronomy was not considered part of physics. And in fact, the first Nobel Prize ever awarded in the field of astronomy didn't take place, what astronomy didn't take place until 1974. And at that time, astronomy was considered to be a part of the physics prize. So that was the case. I would say, though, that it's not that I lost out to say, oh, somebody at UCLA beat my team to the. It's not like the Olympics. The Nobel Prize is supposed to be given out to the single person who, in the preceding year, made the biggest contribution to the betterment of mankind. So you can ask questions. Does astronomy better mankind? I don't think that Alfred Nobel would have said yes. I mean, he could have clearly specified that astronomy was eligible for it. But he was an inventor. You may know that he was the inventor of dynamite.
Yep.
And he holds a patent for dynamite. And that, in my mind, indicated that he, a chemist, really wanted practical things to come that benefited all of mankind. For example, the very first Nobel Prize in physics was given to an Austrian scientist who serendipitously discovered the X-rays. And X-rays were immediately used for medical purposes. So he wanted it to have a beneficial application to mankind. Nowadays, of course, we say, well, when you learn about a black hole, that benefits the human spirit, and I agree. But clearly back then, Alfred Nobel was not so interested in esoterica. He wanted to have things, very much broken down, as you guys like to say, into things that were practical, immediately applicable, and ultimately beneficial for all of the planet. And it's not surprising that astronomy wasn't included early on. My personal encounter with the Nobel Prize was one through this cosmological discovery, and the loss of it was really, multifaceted. One aspect of losing it was that only 3 people nowadays can win a Nobel Prize. Alfred Nobel said only one person could win it, but nowadays we say that the Nobel Committee in Sweden says that 3 people at most can win it. So you might think, well, they're being very generous, but actually it's causing the exact opposite effect. It's causing tremendous amounts of competition and lack of collegiality and collaboration. But be that as it may, the reason that our group didn't win the Nobel Prize, so I was sort of pushed out of the contendership for the top 3 positions by leadership who took over after the leader of the entire project committed suicide in 2010. So I had gotten pushed out of the leadership at that point. And then the reason the other 3 members of the collaboration that were left leading it didn't win it is because essentially we had to retract what we said we discovered. We said we discovered this aftershocks of the universe's creation, when in reality it was demonstrated beyond a reasonable doubt that what we saw was actually sort of dust and schmutz on the lens cap of the telescope. We actually did not see a cosmic signal from the origin of the universe. We saw a much more prosaic signal coming not from the Big Bang, but from tiny grains of interstellar particles that are not too dissimilar from meteorites that you may have seen on Earth, but they're just much, much smaller. So I didn't win it because I was pushed out of the leadership's top 3. And then the other 3 that remained didn't win it because the signal source was ultimately refuted as being the incorrect explanation for what we had originally claimed to say.
So the book's called Losing the Nobel Prize. It's written by our guest today, Dr. Brian Keating, who teaches at UCSD. And obviously you've been to the top of the mountain, but also the bottom of the world. I wanted to get you to talk a little bit about the work that you guys did do down in Antarctica with the telescope that you have. And you have a fantastic TED Talk that everybody should look up. Like Brian Keating TED Talk probably will get you close to where you need to be. But let's talk a little bit about that, because one of the things that's incredible is the South Pole and getting down to that part of the world. It's still super tough. It's not an easy human endeavor, and logistically it's also a monster. So give us some insight on what that's all about.
Getting down to the South Pole is no quick jaunt to the beach here in San Diego. It actually takes the better part of a week at best. And at worst, it can take 3 weeks to a month to get there. So I should say there are 2 types of people that go to Antarctica. There are people that are going to spend the entire year there, which consists of basically arriving in November and then leaving the following Halloween. And then there are people like me who are sane and want to spend a much more reduced amount of time there and spend more time with their family in San Diego. And can you really blame me for doing so? So those scientists like me, the wimpier scientists, we only go from the period, we can only get in or out of the South Pole between December and February. After February 15th or so, the temperature, the ambient temperature at the South Pole begins to drop, and it drops below the temperature at which a military cargo plane has its hydraulic fluid and oil freeze within it.
Whoa.
So in other words, if a plane were to land there, it's perfectly feasible for a plane to land there. But if the engines were to shut off, the hydraulic fluid would freeze up, expand, crack, and destroy the $30 to $50 million cargo plane that you fly in on. So the government is reluctant to do that. So they schedule our visits to arrive in sort of November, December, and then we must depart in February, or else you're there, for the next 8 months. And nobody wants that less than my family and I.
Then that sane professor becomes an insane professor.
That's right. Exactly. He goes clinically insane. And actually, people have gone kind of nutty down there. But let me continue with how you actually get there. So from San Diego, we go to Los Angeles commercially, and then another commercial flight to New Zealand, sometimes through Australia, and then back to New Zealand. And then you land in the North Island of New Zealand, has 2 islands. You land on the North Island and go stay there for a little bit in Auckland. And then you fly to the South Island, and there's a town called Christchurch. And Christchurch was a site of the original departure point for the polar explorers that first discovered the South Pole or reached the South Pole in 1911 and 1912. So these are people led by Roald Amundsen, who was a Norwegian explorer and adventurer, and then Robert Falcon Scott, who's got the coolest middle name in the world. And they led research teams that finally reached the South Pole in 1911 and 1912. So it's only 100 years ago. You have to remember that only like 200 years ago, people discovered that there was a continental landmass at the bottom of the world. So it's the last continent to be discovered. People kind of conjectured about it, but it was almost at the same level that people talk about, say, the lost city of Atlantis. No one had ever really seen it and made it back alive to tell the tale that it existed. So it's a very recently discovered continent. If you think about how much of space, we talk about going to Mars, et cetera, there are parts of Antarctica that no human being has ever been to, still to this day. And there are people there now, we're speaking in April of 2018, there are people now in Antarctica at bases with only 100 people or less, and at the South Pole, there's only about 38 or 39 people there, and they're going to be there until November. So getting back to how you get there, you fly to the city called Christchurch. And then from Christchurch, you get on in my case, the first time I was I've been there twice. The first time I went and I was placed on a giant military cargo plane called a C-130. It's an enormous plane that's capable of carrying about 50 parachutists in military service. This one was a plane that was about 40 years old that we had sold to the Kiwi government. So we had sold it to the New Zealand government. And the New Zealanders are kind of like Switzerland. They're very peaceful. Nobody hates them. They don't have any enemies. So our military, the mascot of the United States Air Force, because we have so many enemies, we want to scare them. So our mascot's the eagle. And we have these, very menacing looking symbols and logos and mascots for our airplanes. On the back of the New Zealand Air Force's version of the same plane, they have a kiwi bird. And you may know a kiwi bird is a flightless bird. So it's not the most intimidating, menacing mascot that you could actually be on. So we fly on that plane. It's an 11-hour flight if you're lucky, and it makes it all the way down in one shot. But the first time I went down, we got about 6 hours into the flight, and then we turned around. And that's past the halfway point for this aircraft to fly and have fuel reserves. So you burn up 60% of your total amount of fuel getting 6 hours into the flight. So we go from when we departed from Christchurch the first time that I went down in 2005 and 6, that airplane went past the halfway point until we found out that the weather conditions were too severe and they precluded us landing on the ice shelf runway that's constructed every year in Antarctica. Basically gets frozen over and then they have to flatten out this icy runway for us to land on. So the plane makes it more than halfway into its fuel capabilities, and they turn around the plane. It's called a boomerang. And that boomerang flight then takes you not back to where you departed from, but it doesn't have enough fuel to make it there. So you land in a tiny other city called Dunedin, which is even farther south from where Christchurch is. So you end up then having to stop, refuel for an hour, and then you get on the plane again for another half hour or an hour to get back to Christchurch. So it's a very draining, it's like a 15-hour flight to nowhere, and it all takes place at 5 in the morning, and then you have to get up the next day at 5 in the morning to do it again. Luckily, the next time I made it down on one straight 11-hour flight, and got there, and it was one of the warmer days in Antarctica, and warm is a relative term, but it was actually above freezing at the coast of Antarctica. The South Pole never gets above that hot, but the coast can get warm. The coast is about latitude 77 or so, southern latitude, so it can get relatively warm, I suppose. But when we get to the South Pole, it's always quite freezing. So when I got to
hold on. Let me break in because I want to color in a little bit here because the Antarctica is crazy. It's still very hard to get to, and I don't know if you've been watching the Ridley Scott show, The Terror, but it's about an Antarctica expedition from way back. It's the John Franklin expedition from the mid 1800s, and they made a choice, A or B, and they chose B or whatever choice it was, and they got locked in, and they everybody dies. And they just found the ships 135 years later or whatever it is. I mean, these things were there forever. That's how remote where you're going and how hard it is to get there. I mean, people don't even go by water for the most part. Like you said, they fly in. And so the obstacles are enormous. Why the fuck would you pick to go to Antarctica to do this work? I mean, it's so hard to do it.
Right. So the heat that we're looking for, the signal of the Big Bang, is in the form of microwave wavelength light, if you will. So it's not visible to the human eye. It's in the microwave portion of what's called the electromagnetic spectrum. So microwaves are used in your kitchen, right? And the way that they work is that the microwave frequency in your oven is tuned to a specific frequency that water molecules get really irritated by. So water molecules will jiggle and vibrate, and they start to jiggle and vibrate enough, they start to boil inside the food that you eat. So if you've ever noticed, you can put something in like a coffee mug, and the water inside will get really hot, but the mug, you can actually pick it up. And that's because the mug, the handle of the mug, the ceramic is extremely dry, intrinsically dry. The water is very wet. So you can actually superheat the water beyond its boiling point. And sometimes if you've ever done that, then the water kind of explodes out of the coffee cup. But the point is that things that have water absorb microwaves like crazy. So you ideally, if you're studying microwaves from the early universe, you don't want them to come traveling through the entire universe and get absorbed in a cloud on Earth or in a water molecule in the Earth's atmosphere. So you want to get as high as possible. You'd actually like to get into space. But space costs about $1 billion, kind of the opening ante to build a type of telescope like mine in space. And it's very difficult. There have only been 3 missions in my lifetime that have actually gone into space, and they all ran over budget, and they're all quite expensive. So the virtue of Antarctica is that the South Pole is about 9,000 feet above sea level. So it's on a giant ice shelf. It's basically a snowpack that over eons has been compressed and turned into ice. And that snowpack has a depth of almost 2 miles. So you're above most of the atmosphere. And then, of course, you have such extreme cold temperatures that any water vapor in the atmosphere above your head back to space, that essentially is too cold to remain in the atmosphere, and it precipitates out. So the coldness and the high altitude contribute to making Antarctica's South Pole one of the best terrestrial laboratories to put a telescope that's trying to see microwaves from the Big Bang.
So when you decide that you're going to go to Antarctica and put your equipment down there, what process do you need to go through to get the approvals to get your equipment down there? And how do you pick what station? Because there's several stations throughout Antarctica. So how do you know where you need to go? And is it just a logistics thing that, all right, this is where people go, whether it's Casey Station or whatever it happens to be?
That's a very good question. So the South Pole is one of 3 research sites that the United States has domain over. The other 2 are the place that we landed at on the coast of Antarctica called McMurdo. And then there's a peninsula that stretches out from Antarctica towards Chile and Patagonia, et cetera. And that's called Palmer Station over there. The South Pole is the highest altitude one of them all. It's at 9,000 feet above sea level. The other 2 are at sea level. So you're above about a third of the atmospheric water vapor just by going to the South Pole. Second of all, the South Pole, when you're at the South Pole, no astronomical sources other than the planets and the sun and the moon rise or set. So the stars and the other objects that we're looking at, those objects just make giant circles over your head all day long, every day, and there's only 1 day and night per year there. So the sun sets, it just set last month in March, on March 21st. That's the beginning of fall in Antarctica and the southern hemisphere in general. And then it won't rise again until September 21st. So the sun is down for 6 months of the year. And so we always joke that these crazy people that spend a whole year of their life there almost, they're actually getting paid about $75,000 to work for just 1 night. And that's a nice deal anyway you slice it. So the United States has dominion over it, I should say, only because we're doing research there. By treaty, international treaty, you're forbidden to do mining in Antarctica or do any kind of natural resource exploitation, looking for oil, harvesting seal blubber or whatever. There's a treaty in place for almost 50 years that says the only people that can go there are scientists and people with a scientific purpose, namely people that are supporting the scientists, the pilots, the chefs, the butchers, the electricians that are down there, the contractors. So it's quite an interesting place to go for a geek like me to be in a place that you can only be in, an entire continent, one of the Earth's 7 continents, that's only accessible to me because I'm a scientist or I'm assisting a scientific research project. It's quite extraordinary.
We're talking to Dr. Brian Keating, Losing the Nobel Prize is his book, and we're getting into some of this. We're talking to a guy that's looked to the back end of space and time, and we're asking him about how to get to Antarctica. But that is, it does kind of go to the problems, and so the situation is you've got to get down there. You spend all these resources and time and money getting your equipment there, making sure that it can survive that environment. But then, when your work comes back, you think you found something. And then when you publish, I'm assuming this is what happens, when you publish in your peer-reviewed journal, someone says, hold on, not so fast, there's dust, and you haven't accounted for that. Does this, I don't want to call into question your science and your intelligence, because clearly you are brilliant, but how does that not get accounted for, or was it unaccountable? Help us understand when the dust shows up, you go, oh, shoot, we didn't think about that. Give us an idea what that's like.
What was so interesting about it, and what is still so interesting about it to me, is that everything that we claimed, except for the ultimate origin of the signal, remains not only true to this day, but is actually, we have even more confidence in its reality and the correctness and the robustness of the measurement that we made.
This episode of the Break It Down Show is brought to you by Lions Rock Productions.
That's us.
We publish, evaluate, and develop podcasts just like this one, consult others to build their own, and create associated content and content marketing strategies.
So if you're launching or expanding your social media presence, your business or your personal brand, or if you just want to take your media presence to the next level,
reach out to us on Twitter
at Pete A. Turner
or at JohnLG69
at the Break It Down Show.
There's 1,000 ways to get a hold of us.
Now enjoy the show.
So even though the interpretation was wrong, the data are the most exquisite data of their kind ever made. And people nowadays, including myself, are really trying to learn more and more from these data, and also to take advantage of the painful lessons that were learned by making a claim that turned out not to be true. So originally, we did attempt to account for the dust signal that we had. So it's not that we ignored it or that we claimed something that's impossible, like you may remember cold fusion. So cold fusion, they thought they could make nuclear reactions take place, basically in your coffee cup. And that turned out to be complete blunder, completely incorrect, irreproducible, etc. Our results, on the other hand, are completely reproducible. They're extremely high quality. But what we claimed were the origins of these data was not correct. And that was that we saw this birth pangs of the universe reverberating in space and time. We didn't see that conclusively. It could actually be that we did see it, but the evidence is sort of equally likely that it could be dust, and equally likely that it could be the signals from the Big Bang's early origin. But in science, you don't want to be 50-50. You want to be 99.99999, so to speak. So we are not at that point yet. But the experiment was not, I shouldn't say, we shouldn't come away thinking that it was a mistake or that we made a blunder or that, we really had to retract the data, because, as I say, the data are exquisite and they're correct. But in science, a lot rides on what you claim. So if you claim that there are particles that can go faster than the speed of light, or you claim Einstein was wrong, you need to bring data. There's a famous joke, in God we trust, everyone else has to bring data. And so we made this huge claim, and in retrospect, we could have just released the data and said, here are these data points, and here's what it seems to indicate about the light itself. But if we didn't say anything about the origin of the universe being glimpsed, there would be no embarrassment. Everyone would be just so enthralled by our data, but they would get no attention for it, and there would be no Nobel Prize for that. So we were very calculating in the way that we did the PR, which is the really surprising thing about science and scientists. You shouldn't just think of us as these dispassionate eggheads that just sit around and ponder these great questions that we don't really care about if we get any accolades for doing so. Scientists are just like normal people, and normal people like to win awards and they like to win prizes. And there's no more, in my opinion, and in most people's opinion, there's no more prestigious award than the Nobel Prize. So in the end, the data are correct. The interpretation was wrong. And I think that the interpretation was pitched, to use public relations language, in such a way to maximize chances of the Nobel Prize for our discovery.
So if you guys figure some new way to take your data and use it, is it still Nobel caliber then, do you think? I mean, you guys have looked to the back end of the universe. Is there something still there?
So there's a lot.
I mean, because no academian's like, we're only going to do one paper with this research. You spend all that money. You're like, how can we publish this, again, legitimately in a lot of different ways?
Right. Yeah. It's kind of like an artist that, has this fantastic painting, or an author who has a fantastic book, and, you struggle with the sophomore slump, so to speak. But in our case, no, until you see the signal, you can keep going and keep trying to hear this whisper of this creationary process. And you can keep doing that forever. Theoretically, my great-great-great-great-great-grandnephews could be doing it too. But on the other hand, at a certain point, for practical reasons, you run out of money, you run out of support, there's something else found, or somebody proves that you can't do it. But for now, no, actually, there's millions of dollars. I'm currently leading a project that has a budget of about $75 million in collaboration with major universities around the world, Princeton, Penn, and Berkeley, and many others. And this project is looking for the same sorts of signals that my BICEP project was looking for 10 years ago. But what's different is that we can learn the lessons of the BICEP experiment. So, the way I think about it, I was just at the Padres game yesterday, and I like going early in the season because they're not mathematically eliminated. That comes in May. But no, I love the Padres. But we
and fish tacos.
Oh yeah, and the churros. My sons love the churros. So when we went to the game, we're thinking like there were 20,000 people in the audience. And if you think about it, like, what if you wanted to hear just one person, say the guy in the announcing booth? So, I'm sure the NSA has ways to do that. But really what you'd have to do is really do a very specific type of listening, of auditory data taking. And if you could do that and you learn from the mistakes of people that have done it before, you can actually improve upon it and go deeper than they were able to go. And so in our case, we learned from these mistakes. And the dust really was a cautionary tale. So when you ask, like, can we still win the Nobel Prize? Of course, but if we can discover it conclusively. But now the stakes are much higher because there's already been a retracted claim of this very discovery. So I think nobody would really jump to the conclusions that they did the day that we made our announcement. These other leaders of this BICEP experiment and at Harvard in 2014, millions of people around the world were watching. It was on the New York Times front page that day, and everybody was talking about how someone's going to win the Nobel Prize from our team. They didn't mention me at that point. That came later. But the problem is sort of this mentality that the Nobel Prize, it conveys the authority of a scientific discovery. In other words, if you don't win a Nobel Prize, you're perceived as less accomplished or less successful or less impactful by some scientists. And even by myself, I write very honestly in the book about how I kind of was one of these people who esteemed the Nobel Prize so much until I really found out that it's sort of the emperor has no clothes. And actually winning it is almost a curse in some ways because you really have nowhere to go at that point. And it's like winning an Oscar. I mean, how many Oscar winners are found, taking drugs and, selling their Oscar for drug money? Yeah. It happens all the time. Now, that doesn't happen. That only happens to 2 out of every 3 Nobel Prize winners in physics. They don't do that. But they do have to sell their Nobel Prizes, many of them, unfortunately, to get medical treatment and all sorts of other things. And they cost, you can buy one if you want for about $400K. That's the cheapest way to get a Nobel Prize, actually, surprisingly. But in reality, I found that at a deeper level, that scientists were coming to idolize the Nobel Prize in a way that reminded me very much of religious worship, that there were the people that were winning it were elevated to a saint-like status. And there were many, many parallels between a religious entity such as any organized religion and the Nobel Prize. I mean, it has a high priesthood. These are the people in Sweden. It's 500 white guys in Sweden who pick who's going to win the Nobel Prize every year. Ultimately, there's the saints, as I said, the winners who have won it in the past. There's the holiday of the Nobel Prize when they give it out. That's watched by millions of people around the world. And then there's the crucifix, the icon, the golden calf. There are these golden medals that they get to wear around their necks forever. And just like with religion, I don't know what religion you are, but if somebody tries to change your religion, even if you don't have a religion, people are pretty reluctant to change their religion. I say in the book, if you've ever had a Jehovah's Witness come to your house and try to convince you to change to that religion, you might find it interesting and entertain it. But ultimately, I wonder about their success ratio because people's religions are very robust. And the Nobel Prize is as close to a religion as most scientists can ever practice.
So it sounds like, from your perspective, it's less a Nobel Prize and more a Nobel curse.
Yeah, that's a good way to put it. Actually, some Nobel laureates, T.S. Eliot, famous laureate, said the Nobel Prize is a ticket to your own funeral. Nobody ever does anything after they win it. And so it's interesting. I met a lot of Nobel laureates in the course of writing the book and my work as a scientist. And almost all of them said that, my last day of joy, of doing research in the lab with my students was the day before I won the Nobel Prize. Because, you just kind of get whisked away like, to like a Hollywood celebrity, and you're forced to do a whole bunch of fundraising and donor events and write retrospectives and serve on panels and so forth. And it's a lot of work. And I salute the winners. I have no problem with the people that have won it. In fact, I was asked to nominate the winners of it. The year after the episode I describe in the book, I was asked to nominate the winners of the Nobel Prize the following year. I could not nominate myself, they told me, which was nice because, that limited the number of choices significantly. But the Nobel Committee had asked me to do something in clear violation of Alfred Nobel's wishes, which was to ignore what he said in his will as to who he wanted to receive it and give it to people which in their minds were met the criteria that they had sort of arbitrarily decided amongst themselves over the 120 years since Alfred Nobel died. And I felt that was a pretty bad thing, because after you're dead, you don't really have, much recourse from beyond the grave. And so I kind of describe in the book how they strayed from his wishes and how they can get back through enacting some reforms to what I think would be the best situation for all of science.
So it sounds like this is kind of the scientific community's dirty little secret.
Yeah.
So I'm a trained scientist. I'm not a practicing scientist. But hearing you speak about everyone's desire, and it's almost like a religion, makes me think that, is there a possibility that somebody's science might be influenced by the prize, and they may rush to some sort of conclusion knowing that it may or may not be accurate, and therefore just to get that recognition and praise? Or I guess the shorter way to this question is the prize influencing science as opposed to science being recognized by the prize?
Oh, I think it's definitely the former. I think there's less of the intentional manipulation of results and scientific lack of integrity suggested by the former question that you're asking. But I don't think too many people do it. That's not to say nobody does it, because there are big things like the cold fusion episode where, these things are touted. They come out way before they're peer reviewed. It leads to a rush to judgment because of the ultra competitive nature of science. And at the apex of this competition is the Nobel Prize. The Nobel Prize is the only prize of its kind in science that really has the esteem that it does. There are no other comparable prizes. And so I claim in the book, and I describe how it's a monopoly. And, monopolies are bad for consumers, right? So if the Nobel Prize is a monopoly, the consumers are sort of the science, interested lay people and the scientists themselves. It has the power to kind of elevate its winners to this ultimate status. And then in so doing, it promotes their universities. There's nothing more than my university would like if I won a Nobel Prize. And there's really no close second in all of science, certainly, but even in society as a whole. So I think there is a pressure to deliver. I was told early on, that I would need to win a Nobel Prize at a certain point.
Jesus.
To really get beyond. I had a young female reader of my book, early draft of it, who told me that she dropped out of science because her father said that she probably wasn't going to win a Nobel Prize, and only people that win Nobel Prizes are good scientists. And she said to me, the highest compliment that I got on the book so far is that, she wished she had my book 10 years ago to give to her father, because it's really, has become this icon. And as I say in the book, people don't get into their promised land, more often than they do get into it, right? So I don't know about you guys, but, I didn't win an Oscar last year. Did you guys?
No.
I also didn't win a Nobel Prize. But so more people experience the kind of episode of striving to win something and not achieving it. And so it's written for anybody in that situation. It could be, I talk about sports and I talk about Oscars and Hollywood, And all those fields have had wonderful reforms that came out of very negative episodes, as you know, the Me Too movement or Title IX reform in college sports for women. But the Nobel Prize had zero reforms. It's never had any outside influence. It's very opaque and it's very clandestine. And so I feel there's a time now to change it and to agitate for reform. And I'm hoping that the book will encourage people to take part in a kind of community that we've developed called losingthenobelprize.org, to try to really reform the Nobel Prize to make it more in concert with what Alfred Nobel nobly had wished for his prize.
Can we ask you some weird, really hard science questions now?
Yeah, sure. Let me get out my calculator.
Yeah, I don't think you need a calculator. But so I'm always fascinated by the multiverse idea, and that's sort of the end of the game that you're playing with, that kind of thing. But also just like if nature hates a vacuum, how come there's so much vacuum everywhere? Like all of space is a vacuum.
Yeah, so it's funny that you say that, because in the book, so Aristotle was the scientist who said that nature abhors a vacuum, hates a vacuum.
Yeah.
But actually, that's really not true. It's he's wrong about that. But yeah, I mean, the vacuum is not that difficult to think about. I mean, if you imagine going into space, you're going to the moon, and you have a big box. And you open that box and you trap whatever's in space out there. There'll be a couple hundred particles in there of different characteristics, neutrinos, photons, protons, and so forth. But the rest of it will be empty, right? So imagine that you look at a couple of different electrons and protons. There's nothing between the two electrons that say you're looking at. That's a vacuum. That's nothing. That's emptiness. But there could be things in there that the possibility for creation called vacuum energy, or the possibility for what are called virtual particles, rather, that can spontaneously come into and out of existence. And so these are fanciful concepts, and yet we have abundant evidence for them. So we know that vacuum energy is real. We know that virtual particles are not virtual in the sense that they don't exist. They're very much real. And so the vacuum isn't empty. It's this bubbling, active, vibrant, resonant fabric of the cosmos that is, sort of alive in a beautiful sense. So it's not really empty. It's empty in the sense that if you average, kind of the amount of energy that's there, it's zero. So there's as many positive things like protons of positive energy as there are negative energy sources, like gravitational forces. And so things are balanced. And so you get at a positive 1 unit to a negative 1 unit, you get zero. But that doesn't mean that there aren't two things in there, right? Positive and negative.
And then when it comes to exploration of the universe, I mean, obviously you guys are looking pretty far back in time. In effect, at least looking at what time was way back when. And telescopes have changed dramatically in the last 450 years. Heck, we have one that's out in space and one that's going further out in space. But I don't know. I hate to say this because I know you guys are all really smart and you see the future better than I do. But have we reached, is Mars the limit of man's exploration in person? It just seems like it's just untenable to, even Mars is, I don't know what the number is, but let's say that there's an 85% chance of surviving and coming back, if it's that high, right? I mean, how do we can't, but we're good at building robots. Is Mars really our, I don't know, 2 lifetimes away limit? Like, or are we really going to try to get out of here and go to Alpha Centauri, do you think?
Right. Yeah. That's a very interesting thing to speculate on. So, when Alfred Nobel died and he wrote his will and it went into effect, it was 1896. And back then, that was still about 4, 5, 6, 7 years before the Wright brothers flew in a plane, and they only flew, 250 feet or something like that.
Suckers.
And now, and then less than the time between that and say the first people got to the South Pole 10 years later, they were starting commercial air traffic. And then you go another 20, 30 years beyond that, and there's jet travel. And then 10 years later, in the 60s, we're on the moon. So I think if you had asked, Brian Keating in 1895 on a wax cylinder Victrola, whatever podcast they would do back then, he or she would say that is, it's not impossible. And in physics, we like to say, that which is not impossible is mandatory. So if something is not forbidden, we're going to figure out a way to do it. And whether that means that we have to harness energy more efficiently, the sun is this enormous source of free energy that just, we don't have to pay any people at the pump, right? We just get all this energy, and we have to create interesting ways to mine it. But we've learned how to do that very effectively, and we're going to continue doing it. So I don't think Mars is the limit in any stretch of the word. I would also point out that there's parts of the world that we haven't set foot in. As I said, Antarctica, there's places undersea where 70% of the planet's covered in water, and that's a lot more habitable than going to Mars. I definitely don't think we should look to other planets as the source of saving what we've done to planet Earth. But I think they're much more reasonable and economic places to go. But for the spirit of exploration and the human endeavor, which is always to find new frontiers, that space is this limitless frontier. It's not the final frontier; it's an infinite frontier. And so I do think that there will be emissaries from the planet that will eventually reach other solar systems. Some other time we can talk about the probability of life on other planets. That's not for today, but it's something I think about a lot as well. And of course, that's intimately related to the origin of the universe. You can't really have these species that exist in other planets that we could potentially interact with on an intelligent communication basis, or even shake hands with, unless the properties of the universe were such that such life forms similar to us could exist. So it's a really wonderful thing to be able to speculate how life and humanity are all connected to the origin of the universe. And, hopefully my book does a little bit to engaging the reader with the wonder of what a scientist gets to do. I never thought it was possible to be an astronomer, right? I always thought it was like, is someone going to pay me to be a wizard? It was just not going to happen. But I get paid to do this by you guys. I'm a state employee, but I would do it for free. But don't tell Jerry Brown that.
Because he'll take you up on the offer. Your book is called "Losing the Nobel Prize." You are Dr. Brian Keating. I think Phil has one more question for you.
Yeah.
I don't know what kind of life forms are out there, but at one point, people on this planet thought it was flat, right? So
correct.
Until you actually see something and realize that, hey, you don't fall off the edge of the planet, and it is round and spherical.
Mm-hmm.
That people would say, okay, there's no way. It's a very narrow-minded view to think that we are the only life forms, that exist or on this planet. And to me, that's the Earth is flat type mentality where we have no idea what's out there. I mean, we could be, just the speck on. What is really out there as far as the amount of other things in
that's absolutely right.
Space.
Yeah, I mean, we kind of have this bias, and I do speak about that in the book, how ever since humanity sort of had the intelligence to kind of look out and gaze out into the universe from Galileo and Copernicus and Kepler on, we speculated that we might or might not be the center of it all. Like we might be the center of the solar system. We might be the center of the galaxy. We might be the center of the universe. Now there's this theory of the multiverse, which I discuss in my book, which says that not only are we not the center of any of those other four things, we're not the center of the multiverse either. And that's kind of the ultimate expression of humility. I say this this principle called the Copernican principle suggests that there's no specialness to us on Earth, and it typically has been referred to how the location of the Earth in time and space are not fortuitous, propitious in any way. But now I would say the next thing might be that what we're made of might not be special in any way, and that as the famous scientist Jeff Goldberg said, life finds a way in Jurassic Park, right?
Yes.
So I think to think that we, are what life is going to look like on other, even if it doesn't look like us, but it has properties similar to us, who knows? Maybe the life that we encounter will be made of silicon or made of some other element, or that this notion that you have to be located this exact distance from a sun exactly like the sun, our sun. Maybe that will be seen as ridiculous as thinking that the Earth is the center of the universe 400 years ago when Galileo first turned a small telescope to the heavens.
He is Dr. Brian Keating, and man, that was super fascinating. Yeah, I want to play some what if stuff and throw some rocks in some pools and see what kind of answers we can come up with, because that would be cool. But for right now, thank you so much for coming on the show with us. It was really neat to have you on, and everybody should definitely go pick up a copy of the book, because what I've seen already is fantastic. Losing the Nobel Prize, a story of cosmology in motion. It's so cool. So, hey, everybody can grab Brian Keating's attention on Twitter for sure at Dr. Brian Keating, or you can go to his website, briankeating.com. Hey, thank you very much, man. I appreciate it.
All right. Love you guys. Take care.
Love back at you. All right.